everybody. In today's video we're going to discuss chapter 8.2, which deals with areas in the plane. So what are areas in the plane? Well, let's look at the first graph here, which is colored in green. So in order to find the area of the striped region, we have to take the integral from a to b of f of x minus g of x. So f of x is the function that is above, so the upper function. So this right here would be f of x. G of x is the function that is lower. So this right here would be g of x. Now, what if your graph looks like the one colored in pink here? Well, then f of x is the rightmost function, so this function right here, and g of x is the leftmost function, so this function right here. So let's do a couple of practice problems and hopefully this will make more sense as to its application. Okay, so this first problem is number 16, and they give you y equals 2x minus x squared and y equals -3, and they ask you to find the area in between the points of intersection. So first we have to find the points of intersection. So I would set these two equations equal to each other and then solve for x. So x winds up being -1 and 3. So now let's go ahead and graph these. Okay, so step 2 of this problem is to draw the graph. So we know that the place where the functions intersect is at 3, -3, and -1, 3. -3, I'm sorry. And we determined that from our calculations previously. So we are trying to find the shaded area, the shaded region. So how do we do this? Well, let's go ahead and set up the integral. And it's very easy to set up the integral when you have like a visual depiction of what you're trying to solve for. So it's going to be the integral from -1 to 3 of, so my upper function is going to be this one right here, the 2x minus y minus x squared. Minus my lower function, which is the blue line right here, which is -3. So I can evaluate this in my calculator using Math 9. And I believe my answer is, I don't have room to write it down there, 10.666 repeating. All right, so that was a pretty easy problem. Let's go on and jump into something a teensy bit more harder. A teensy bit harder? Okay, so the second problem gives you y equals 2 sine x and y equals sine 2x, and it also gives you the domain, x is in between 0 and pi. So this is a type of problem where actually graphing it first is more helpful to find the points of intersection. So that's what I've done here. It's quite trivial. If you're not too confident with your unit circle skills, you can use your calculator depending on what your teacher wants from you. But obviously you can tell that the points of intersection are 0, 0 and pi 0. So I want to find the area in between y equals sine x and y equals 2 sine x. So I set up my integral from 0 to pi. The upper curve is the blue one, which is y equals 2 sine x. minus the lower curve, which is in orange here, which is sine 2x. So I'll put that into my calculator to evaluate, and I will get 4. All right, let's try one more problem. Okay, and finally, the last problem says x equals 3 sine y on the cosine of y, on the square root of cosine of y, and x equals 0. And it also gives us the domain. Y is in between 0 and pi over 2. These are your intersection points. This is your A, this is your B, and you can also clearly see it when you graph that 0, 0, and 0 pi over 2 are your intersection points. So what's weird about what they've given us in this problem is that it's x equals instead of y equals. So this automatically alerts you that the y-axis is now the new x-axis. So these points, pi over 2, should go on the y-axis. So we're going to go, I went ahead and did the graphing portion. So you can see that we're trying to find the area in between this curve, which is 3 sine y times square root of cosine y, and this curve, which is just x equals 0. So the rightermost curve is the one in black here, 3 sine y times cosine y, and the leftmost curve is the x equals 0 line. So I just put in 0. So I can plug all of that into my calculator and evaluate, and I get the answer as the area, the shaded region, equals 2. So that's all for this video. If you have any questions or comments or concerns, go ahead and leave them down below. Thank you.